How many of you have gone through the preparation? Raise your hand. All right. So these many members, that's really good. So okay, let me start with the Revant. Revant, can you hear me?
Yes, sir.
Okay. So can you state few of the methods by which we can actually prepare uh, the hydrogen? In doesn't matter laboratory method or whichever the method, but you quote some method. Okay, please.
In laboratory method, we will use Jaden, sir, as reducing agent
Okay, with
with an acid.
an acid. That acid could be anything
Yes, sir, which gives H plus.
which gives
Ah,
H plus. Okay,
ah.
so can I use HNO3 also?
Yes, sir, 2HNO3.
Fine, fine. Okay, fine, buddy. So, all right. And what will happen if I'm taking zinc with base like NaOH? Will it
We'll get, if we take 2NaOH, sir, we'll get sodium zincates.
sodium zincate along with hydrogen? You are saying, right?
Yes, sir. Yes, sir.
Okay, Revant. So the other members who have raised the hand. Yes, Nihal, can you hear me?
Yes, sir.
Nihal, can you quote some method? Can you tell me the first reaction? Will it undergo, uh, will it produce hydrogen gas or there is any complication with that?
Sir, it will produce, sir, if we take 2HNO3.
All right. Okay, buddy. And the other one is Mr. Uh, Vardhan, Sri Vardhan.
Yes, sir.
So is there any problem with the first one? Is it okay?
It should be dilute, sir, but still, since HNO3 is very strong, I think there maybe
It should
no
give.
complication.
Very good. Fine, fine, fine. The next one, I think anyone? Any other person wanted to make any remark on that, whether it will give or not? Any other? Okay, no issue. I will come to it. I will explain you. Okay, the right answer is it will not evolve hydrogen gas. Okay. Not only this, you are supposed to tell me the concentration of H2SO4 also. If you have taken dilute, my dear, then it is definitely going to give you hydrogen gas. But the moment if you are taking concentrated H2SO4, concentrated, you won't get any hydrogen. Hydrogen will not be the product. Okay, so these precise things I was expecting from you, but it is all right, my dear. No issue, no issue. Yes. Okay. Any other student would like to tell any other method apart from these laboratory method? What are the other methods that you are expecting?
Water gas
Sir,
shift.
ZN.
Sorry.
Sir, only
Mm-hmm.
laboratory.
Only laboratory. No, it's not necessary. You can tell any
Water
method.
gas.
Water
Water
gas.
gas shift.
What is water gas? What is water gas?
Mixture of CO and H2.
CO and H2. Do we have any other name for this mixture as well?
Gas.
Water. What's the name of that?
Syngas.
Gas.
Gas.
Mm-hmm. We used to discuss syngas, huh? Syngas and
Synthesis
water.
gas.
Synthesis gas, short form is syngas. That is how it is pronounced. Okay, fine. Any other method?
Sir,
Sir,
electrolysis of
from
alkaline or
methane.
sulfate.
Uh, Electrolysis is also one of the method. water's electrolysis, right? H2O, pure water or some mixture we are supposed to take?
No, sir. Alkaline or slightly acidified.
Okay. Okay. So can you tell me what is the role of slightly alkaline or slightly acidic?
Sir, making the
Ions
solution
will be
conductive.
Yeah, that's really, really great. Very good. Very good. Okay, everyone. Now let's start that. Any other method? Anyone would like to tell? Any other method
Or
apart
from
from
methane.
methane
Steam
means
over red coke.
yes, CXHY means any hydrocarbon if you are heating in the presence of steam, that too at very high temperature, nearly around 1000 degrees centigrade. Okay, so you are going to get CO plus H2 gas. That's what you wanted to tell? Yes or no?
Yes, sir.
Any other?
Passing steam over red hot coke.
Passing steam over?
Sir,
Red hot coke.
electrolysis of barium
That we,
hydroxide.
and that we are already done, na? Alkaline and acidic.
Barium hydroxide.
But if barium hydroxide is basic, na, which is alkaline. So
Yes.
just by okay, so it is already covered. Any other method, guys?
Sir,
In
CO with C. CO with H2O.
CO with H2O, that is water gas shift reaction, right?
Yes.
Where it will. Any other?
Coal gasification.
రేపు వాడికి తెలియదు కరెక్ట్ తప్పలే సార్ అవి కింద జాకెట్ కింద
Sir, we
పడుతుంది
can't hear.
వాకింగ్ ఎంతమంది పైన పెట్టారా అయితే ఇల్లు కూడా ఉంటుంది దూరం అన్నదా అంటే కొత్త ఇల్లు
Guys, am I audible? Sorry,
Yes, sir.
because of some power failure which is happening quite often today. You might face this problem right throughout the lecture. That's not in my control, guys. And don't panic in between, okay? That there is no problem from your side. It is the problem associated with the power supply here. Okay. So let's hope that in between there should not be any disconnectivity. But my lecture is still in recording, right? It's already getting recorded. That's really great. See, now listen. That what will I tell as a student if I have to tell you the various method of preparation? My screen is visible to all of you? No.
No, sir.
No, sir.
No. Okay. Okay. All right. Now I think is it okay? Can you see the screen?
Yes.
Yes, sir.
Right. So now look at how I will start. If I have to tell you, if there is no boundary of commercial or the laboratory method, how I will start? I will think about. So, what are the method by which we have seen the hydrogen coming out in our lower classes? Lower classes means till 9th and 10th, whatever the book that you had. In that, what were the method? The first thing I am able to recall is that, sir, active metals like sodium, potassium, rubidium, and cesium, these metals are really, really powerful. And they are such a powerful metal that they are going to take out the hydrogen even from the water. And this will give us NaOH and hydrogen. Don't write anything, guys. Please don't write. This is just an approach I am telling you. that how to think about certain thing which you have already read. Just because you are reading here in class 11 doesn't mean that you should forget all things which you have studied in the past, right? So try to recall those things, give us stress little bit, and then move with the topic, right? So sodium with water will give. Now, now what you have to understand here in class 11, that let's understand what is happening. So my dear, active metals are really a good source of electron. What are they? They are a very good source of electrons. So essentially what they will do, sodium actually going to release electron. It can ionize very quickly. Inside water, you know, hydration is also there. So electron is given there. That electron, my dear, is taken up by the hydrogen, which is already there in positive, partial positive form. This will be taken by that. The moment it takes that electron, the moment it takes one electron transfer is always shown by half arrow. The moment it takes an electron, oxygen is going to take both the electrons shared between that. So it will become H dot, means having just one electron, the other species will be OH minus. Now, interestingly, it's not the only one H dot that is created in the mixture. So many such H dot radicals will be there, and you know that hydrogen in atomic form is not stable, so they will combine very quickly and release heat. Agreed or not? So the overall process appears like that sodium is removing the proton from here and forming hydrogen gas. So if I look at the reaction in this way, then I have, you know, many things that can be there, because here it is a losing its electrons, so it is undergoing oxidation. This process is oxidation. So the species which is undergoing oxidation acts as reducing agent. So it is basically a reducing agent. So from here, I can generalize that not only this, okay, sodium reacts with the cold water. There might be some less active metal which might react with warm water. There might be some even less active metal which react with steam. So I will first give priority. Do we have something uh, to do with the water by making any change? So this was the first way of thinking. Like, so it's not about sodium, my dear. It could be any metal. It's just a matter of whether you are heating it uh, or it is reacting with the steam. The temperature may vary, but it is going to produce certainly. Now the next question is, sir, does it mean all the atoms in the periodic table is going to produce hydrogen? Answer is no. No matter what you are going to do with the copper, means if in electrochemical series, if you remember little bit about the order, you'll figure out the metals which are below hydrogen like copper, silver, mercury, platinum, gold. Very few metals are below hydrogen in the electrochemical series, and above, if you want to talk, most of them are above. Zinc, Mn, there are many of them, right? So copper, no matter what temperature are you going to heat with, it is not going to produce anything. Means it is not going to produce hydrogen, H2, right? Because it is one of the most least reactive metals. These are least reactive metals. Okay, so this was the first thing. Next question comes, sir, okay, I understood with water it can't do anything. Will copper do anything with HCl kind of thing? Again, answer is no. With non-oxidizing acids, HCl is a non-oxidizing acid. How do I know that? Sir, chlorine is in -1 state. So if it is oxidizing acid, then it should further undergo reduction. But from -1, there is no lower state than -1 for chlorine. So that is what, that's why I'm using the word, it is non-oxidizing acid. Are you getting? I am not going to give you time to make a note on all these, right? I want you to just listen and settle these things in your brain. I'm also going to teach the things which are given in the books. But these things are going to help you certainly in when you are attempting a fresh question completely, how to go through it, right? So Don't write anything from here. Now let's look at the problem that is happening. Okay, sir, fine. If something can remove hydrogen from water, water is extremely poor electrolyte, right? So its ionizing tendency is very, very poor. You can say that one, even if we have, say for example, 1 mole of water, 1 mole of water, very less amount of H plus you are expected to get from this. Very, very less, extremely less, right? Generally in water, I'm telling you, if there is nothing added inside it and temperature is 25 degrees centigrade, you'll be really surprised that 10 to the power minus 7 mole per liter H plus ion you will get. Minus 7 mole per liter. 1 liter of water will contain 10 to the power minus 7 mole of H plus. So that is so poor. Now, sir, what if we are going to give with the same metal some good acids? So will it do? Answer is yes. Like zinc, if it can remove, like sodium also, if it can remove H plus from water, it can certainly remove H plus from this HCl. So it is going to form NaCl. You are going to get hydrogen gas. So sodium can remove this hydrogen gas from any acid. You can derive by yourself. You are endless number of acid, my dear. H plus should be there, and you will be getting CH3COONA and plus hydrogen gas. Right? You can take here H2CO3. You can take here any acid, my dear, any acid. Even HCN, you are going to get NaCN, Na plus, Cn minus plus hydrogen. Right? Okay. Now, at the beginning, I told you, I asked you a question that do you think that HNO3 is going to release the hydrogen gas? And I said no. You guys were saying yes. I said no, not at all. It is not possible. What is the problem with this HNO3? Because we have seen that anything which is supplying H plus ion, zinc can react with that and will produce hydrogen just like sodium. But what is the problem happening with HNO3? So the problem in HNO3 is there are two species which can act as an oxidizing agent. The species number one is proton itself. The other species is nitrogen. Nitrogen is in +5 state. If hydrogen is participating and it is acting as an oxidizing agent, in that case, definitely you are going to get. But the problem here is that this nitrogenous part in acidic medium is more powerful oxidizing agent. And what happens in that case is that this HNO3, depending on its concentration, it is going to form various products of nitrogen. So nitrogen will go from +5 state. I'm telling you guys, it forms N2O. This zinc, depending on the concentration of this, can form even ammonium nitrate. Basically, ammonia it forms -3. You can see it is in +1 state. And if you are taking concentrated, it will form even NO2. So you can see that because of the participation, even with dilute, we are getting this, normal, we are getting this, and with concentrated, we are getting, in all the cases, this is participating. Then probably your question would be, sir, do we have any case of HNO3 where we get hydrogen? Do we have any case? Okay, because nitrogen is participating. So some case would be there, na, sir, which can, reduce this H plus into H2 in any condition of HNO3. So yes, there is a case, but that is very particular with the two metals and both starts with M. That is Mg and Mn, magnesium and manganese. Only and only these two metals are there, my dear, with HNO3 that is very dilute, ultra dilute, very dilute. It is going to form, of course, nitrate, MnNO3 voltwise, along with hydrogen gas you are going to get. So except these two metals, so you will be in the trap, I'm telling you, because if you are good in understanding chemistry, you might undergo trap if you don't know this information, right? So they will be giving the question like the way I asked here. Tell me, if zinc is reacting with that, are you going to get the hydrogen gas or not? So the crude reality is, with zinc, HNO3 will never give hydrogen. These are the only two metals. Now you'll ask, sir, do we have any such possibility, any other possibility with the other also? Answer is yes. You know, even H2SO4, when it is taken in concentrated, zinc is not going to give you hydrogen. Rather, you are going to get SO2 gas. Again, at concentrated, the sulfur is in +6. That undergoes that basically participate in the reaction rather than H plus ion from here, right? So please understand, concentration is also very important. Now with only concentrated we have problem. If it is dilute, there is no problem, my dear. So why? Because oxidizing power wise, if you will ask, HNO3 is one of the most powerful oxidizing acids. Oxidizing acid. Right, and thereafter we have H2. After HNO3, if you will talk about strong acid, I'm telling you based on the oxidizing power, right? Oxidizing. H2SO4 is a mild oxidizing agent. It's not a powerful. And S3PO4 is extremely poor oxidizing agent. So please keep that thing in your mind, right? And HCl is a very strong oxidizing agent, strong acid, but non-oxidizing. It is not strong. S3PO4 is not strong. It is moderate only, but you can expect with its oxidation number that it is a very powerful oxidizing agent. But it is not like that, guys. It is the nitrogen only which is creating such a big pain. Apart from that, we have very mild oxidizing power, that in H2SO4. Okay. So now you have already explained everything. So here is the thing that you are supposed to write. Please go ahead. Laboratory method. So either you can take zinc, H2SO4, make sure it is dilute over here. Okay, and then write down this. I haven't balanced the reaction because I'm interested in the products and the reactant. Okay, so zinc plus NaOH, when you are taking, this is forming this. Right, so with acid also, with this also. If you want to add extra points, those were the extra points which I told you, which you are supposed to write. Otherwise, it is enough. My dear, the question is, can it give hydrogen with HCl? Answer is yes, it will give. Specifically, zinc is given in the laboratory. What might be the reason behind it? See, there are many angles to a chemistry reaction, right? There are many angles. I will tell you the most important angle right now is finance. If something which is really expensive to do, no matter whether it is going to give us hydrogen, we will not be using. We will try to avoid unless we don't have any other method left. Like you know, I told you, my dear, that sodium can release even with water. So your first question should be, sir, then why this is not given in NCERT? So when you are reading about the metals, that is given, but when you are trying to practically obtain, my dear, obtaining sodium is highly expensive process. So if you want to just obtain hydrogen with that expensive metal, it is not economically favorable, right? So that's why we don't commonly use sodium. Is that clear? Is it making sense? But yes, it is going to give us hydrogen. So if economic Perfect. Guys, could you please confirm? Is it okay now?
Yes.
Okay, fine, guys. As I told you, there is today for specifically today. I don't know. It started from the morning, but it is going on. Okay. All right. So, what was the last point which I was telling you? Could you please remind me? Can you see the screen now?
Yes, sir.
So what was the last point which you actually heard related with HNO3? Did I explain? Did I explain H2SO4 concentrated and dilute version? Did I tell you? Yes or no?
Sir, you said commercially feasible thing, sir. Economically.
Okay, okay, yeah, economically, fine, fine. So as I was telling, there are various possible methods, but we will be choosing the things which are economical, and especially when you are producing for a large extent, then certain setups which are really expensive can be taken into account, provided overall, uh, when you are going to sell the whole product which is obtained, that should also be economically viable in a large scale, right? So for laboratory scale, the economics is not much of concern because we hardly wanted few, but out of the given resources, we'll be figuring out the one which is cheapest available there, right? So fine. So you please write down these two reactions, laboratory method, zinc plus H2SO4. Uh, Make sure that it is dilute, and please, if you want to note it down, please make a note over here. The same zinc will not give hydrogen with concentrated H2SO4. It is going to give you ZnSO4 plus SO2 gas, my dear, very, very important, right? So this is going to participate. This sulfur is going to participate from +6, which is going to +4, going from 0 to +2. Please
Mummy.
mute. Please, Tony. Okay. Please make a note on this, right? All right. Now the next question that you might ask about NaOH is, sir, the way we are using zinc with NaOH, can we expect the same if we are using sodium with NaOH? Can this happen? Or even if calcium with NaOH, will it happen? So answer is no, my dear. Okay, it's not possible with that. Then how to know in which case we have that possibility and in which case we don't have that possibility? Now I will give you an idea to think about that, right? Tell me the nature of oxide and hydroxide. Nature of oxide and hydroxide. When it comes to nature of oxide and hydroxide, how many different types of these things you already know? So one is basic oxide, sir, basic oxide or hydroxide. Then there is, sir, neutral oxide or hydroxide. So then there is another name, amphoteric, sir, amphoteric oxide and hydroxide. Then there is acidic, sir. Is it? So when it comes to basic, we have a long list, isn't it? So most basic, if I'll be talking about all the alkali metals, group 1, guys, am I audible? To cesium hydroxide.
Yes, sir.
In alkaline earth metal, there is one problem. Beryllium hydroxide you can't take, or the oxide of beryllium. So beryllium oxide is present over here, amphoteric range. So beryllium oxide or beryllium hydroxide, you can make this as an important note while writing, okay? So beryllium oxide and beryllium hydroxide we have there, except that magnesium hydroxide is basic and you can go till barium hydroxide, strontium, barium hydroxide, all of these are basic. Basic we have TLOH, thallium hydroxide. Basic, if you want to ask, then bismuth hydroxide is also basic. So I'm going from now S block towards P block. Now in D block, if you'll ask, still there are many which are basic, and I am telling you, see, scandium, titanium, vanadium, there are many scandium hydroxide is obviously basic in nature. Titanium oxide and hydroxides are basic in nature. Not all the oxidation. Vanadium, especially when you are moving up, that become amphoteric, and one of the oxide is reported in NCERT in both ways, amphoteric as well as, that is V2O5. But most commonly which is used in chemistry, I should tell you. So in D block, iron hydroxide is considered to be basic, FeOH whole twice, both the oxides and hydroxide, +2 and +3, right? So these are basic. When it comes to neutral, my dear, there are three, as if now I will tell you: N2O, NO, and CO. Okay, N2O, NO, and CO. These are neutral, means it will neither react with an acid nor react with a base. Means you can't expect any reaction of N2O with NaOH at ordinary temperature, nothing will happen. Right? You can't expect N2O to react with an acid like HCl, nothing will happen, my dear. Getting my point? Means you can't expect its reaction with acid and base. So that's what the neutral means. Amphoteric is the one which reacts with both of them. So beryllium, in the entire S block, we have just one metal, that is beryllium, whose oxide and hydroxide is basic in nature. Okay. In D block, we have many of them. So let's figure out in P block. Although in P block also we have many, but those who are commonly used, I wanted to just draw it here, like aluminium, Al2O3, or ALOH whole thrice. This is amphoteric in nature in boron family. Although I will tell you the gallium is also amphoteric in nature, right? Okay. Then in carbon family, my dear, both the oxide SNO, SNO2, PbO, PbO2, they are all amphoteric, right? This is in the carbon family. Then in the nitrogen family, I already told you that bismuth is basic. So above bismuth, in +3, we have some sort of amphoteric character shown by the. But again, as I told you, I will not be using many of those. So these are something which is really common. Really common. SNP block, I told you. Now there is some sort of compound I'm going to tell you from D block. Like chromium hydroxide, CrOH whole thrice, is having amphoteric nature, just like AlOH whole thrice. Right? So this is another. Another is again very common is zinc hydroxide. That is also very common. So if you can keep just these many points, I think you will be able to answer many questions based on this. So now it is amphoteric. The moment I said amphoteric, it means that zinc hydroxide can react with obviously acid, means it will be forming ZnCl2 plus of course water, H plus, and this is first reaction. The other one with the base like NaOH. Now my dear, the actual reaction is that zinc takes out 2OH minus and becomes like this, -2. This is a complex, right? Where all the OH is coordinating its electron to zinc +2 ion, right? This is the way it used to react. I haven't balanced this reaction, please understand that. So if you want to write it down with the balanced way, like it is Na2 ZnOH whole 4. But you know, earlier it was represented like this, that Na2, how many zinc? Zinc 1. And how many water molecule can I associate here? So 4 hydrogen means 2 water molecule, 2 H2O. Now how many oxygen left? 2 oxygen. So it was reported like this. So in many a book, if you will see, just this part is given to you. Na2ZnO2. Okay, that thing you will see even in case of aluminium. Like aluminium hydroxide, as its nature is amphoteric, it will react with HCl and form AlCl3 plus water, and the same AlOH for thrice is going to further react with base like NaOH, and it will form AlOH whole 4 minus, right, and plus water. So if you want to balance it, it is NaAlOH whole 4. So there will not be any minus. Now again, if you write down NaAl, you try to write down in the form of Al2O3, because that's the natural oxide of aluminium. Try to write down in the form of negative ion aluminate. Then again you will see that the water molecule from here, the way we have represented zinc like this. So this part is known as sodium zincate. In the same way you can do over here also. So the point here is those metals whose hydroxide is amphoteric in nature, they are going to react with the base directly. Of course, their hydroxide is going to react, but corresponding metal also directly can react with NaOH. So basic NaOH, you will get Al, NaAl. If you are going to directly heat them without taking aqueous thing, in the molten case, you will be getting Na3. Wait a minute, AlO2. Many combinations are there. NaAlO2, you can see that it is in +3 state. The oxidation number should be maintained. Okay. So the combination like this. And in this particular case, I am telling you, when these metals are reacting with NaOH, they are going to produce hydrogen from +1 to 0. How do I know that? Because aluminium from 0, it is going into +3 state, means it is undergoing oxidation. Na? So there has to be someone which will undergo reduction. Na plus you can't reduce from +1 to 0 state. It is one of the most reactive atoms, right? Then oxygen is already present in -2 state. So which one is left then? It is the hydrogen which is going from +1 to 0 state. So it is possible to get reduction with. So that's what I was trying to tell you. It's not only zinc, it is aluminium also. For that matter, you can even consider chromium also. It will react in that way. So you can make a point over here. Metal whose hydroxide is amphoteric in nature, metal whose hydroxide is amphoteric in nature, they are going to react with NaOH, and they are going to release hydrogen.
Sir, once
Got
again, can you repeat?
Yeah, I am repeating that. Metal whose hydroxide is amphoteric in nature, not basic, my dear, right? Not basic, amphoteric in nature, they are going to react with NaOH and will produce hydrogen gas. So the whole procedure, how does it happen? You understand in this way that the zinc is first reacting with water. You can understand, just for understanding, I'm telling you, it is producing zinc hydroxide the way sodium was producing and hydrogen gas. And this is reacting with NaOH and producing this ZnOH whole 4 -2. So if this reaction is, if the second reaction is possible, then only the whole process is going to take place, because you have already created. Because if it is not amphoteric, it will not react. So if you know the Le Chatelier's principle, means the equilibrium process, if it is not going here, this reaction will revert back. So this process is not going to happen properly, right? So that's the reason I was telling you that it should be amphoteric. And now you can obviously understand that the calcium is not going to react with NaOH for the same reason that calcium hydroxide is basic. So base will not react with this, so this reaction will not happen. You can't expect this reaction with calcium. Now if I'll ask you, do you think that this reaction is possible with boron? Like NaOH I am taking and I am heating very strongly, and that to NaOH in the molten state I am trying to take. Will this happen? Answer is yes. Here also it will be possible. Fused NaOH can react with boron. Now why is it so, sir? Because the boron oxide is not amphoteric, but my dear, boron oxide is acidic in nature now, and any acid can react with the base. So the whole point was that the species which is produced after the action should react with NaOH and convert. So either it should be acidic or it should be amphoteric. It should not be basic. So the bottom line is metal whose hydroxide or oxide is basic in nature, they will not react with base like NaOH to produce hydrogen. So I can frame so many questions, I'm telling you, based on this simple logic. I can frame so many questions. All right. So, but that's it for the case. So these two are the most important, and apart from that, I told you many method. Now, similarly, my dear, commercial scale preparation. When it comes to commercial scale, as I told you, the economy is the most, because commercially you want to produce not just 1 mole of hydrogen, 2 mole. You want to sell it, right? For that, suppose an investment of some 1,000 crore is there, but globally, if you are trying to sell it and annually you are able to produce 2,000 crores, then it is worth to establish 1,000 crore machinery to get that. So commercially, generally heavy plants are involved, and we used to choose the method which is too much economically viable, right? And on a larger scale. So electrolysis is not a very simple method, right? If you have to produce hydrogen in a great amount, it is not a very convenient method. But if you have to produce in a very large amount, and uh, when the setup can be drawn in crores, then you are supposed to fix this kind of plants. So electrolysis is one of this method. So what happens? Because the pure water is not a good conductor of electricity, so we take alkaline water for electrolysis, like barium hydroxide, OH whole twice is there, or aqueous sodium hydroxide. You can take any other means also. At the same time, not only basic, my dear, acidic, slightly acidic thing will also undergo this thing, but there is certain complication with that. I will tell you later on through the electrolysis, but please make a note first. Okay. So what are the reactions that you can expect on different things? So let me quickly brief, and thereafter you note it. Okay. Just a minute, guys. So in electrolysis, the word electrolysis means electricity is used to break down. Lysis means breakdown of the molecule. So electrolysis of water means water essentially is going to be broken down by using electricity in hydrogen and oxygen. But the whole setup, if you want to see that how does it happen, sir? So obviously there will be a cathodic plate, and then there will be an anodic plate. My dear, what is cathode and what is anode? You are already aware, but still I will tell you a little brief of that. This is the battery, my dear, negative terminal and positive terminal. The positive one is going to create positive charge on the plate. Negative one is going to create negative charge on the plate. Now, the one, right, suppose I am taking inside this, if I am taking alkaline source, like say for example, I am having OH minus barium plus 2 and OH minus, of course, water is there, my dear. So you can understand, and this water is certainly undergoing ionization, very poor ionization, but it is going to, so OH minus. So now you can understand in this way that this plate, the positive plate, is going to attract negative ion. So we have OH minus as the negative ion. But the negative plate is going to attract the positive, and we have, for that matter, we have two different positive ions, hydrogen and the barium plus 2. But it will be quite difficult for the barium plus 2 to undergo reduction as compared to hydrogen. As I told you, relative tendency of the different metal is seen by electrochemical series. On that series, the metal belonging to S block is at the top, most reactive, S block. Out of those two also, again, alkali metal is better, thereafter alkaline. Thereafter, most of the metal comes from P block, like I will tell you, aluminium. Okay, so the overall order, if you are interested in, I will tell you like this, that Li, K, Ba, Sr, Ca, Na, Mg, Al, Mn, Zn, Cr, thereafter Fe, Cd, Co, Ni, Sn and Pb. And thereafter we have hydrogen. But still I have left many of them. Just I am trying to give you an idea that just look at this series and try to have an idea that how the reactivity varies. So first of all, you can see till here, they all belong to S block. That's what I was trying to tell you. You can write down the reactivity series, and under that heading you can write down. So these all belongs to S block. You can see this is most metallic P block element. This is P block. Okay, I haven't included most of them because of many reasons. One of them is their practicality. We don't have so many metals, so many uses of the other metals, right? So this is mostly used. So P block is not only present there, you can see that P block is over here also. The carbon family member. This is from boron family. And thereafter you see the whole lot of D series. All of these belongs to D. Right? Mn, Zn, Cr, Fe, Cd, Co, Ni. And before hydrogen, I mean just below hydrogen, those metals like copper, Ag, Hg, Pt, Au. You can understand that these are least reactive. Least reactive. They are most reactive. So with this series also you can predict that, sir, hydrogen is less reactive, means as compared to barium. Barium is over here. So barium going into plus 2 is very easy. It is most reactive, but coming back to barium is very difficult, right? So that's why barium does not undergo over here rather. So we define this characteristic based on the electrode potential value, because that is related with the electrochemistry. I don't want to go into that deep here, but I'm just giving you an idea that it is much easier for barium to go into plus 2 rather than going from barium plus 2 to barium 0. So hydrogen goes over here. So my dear, the two possible reaction that is occurring over here. So H plus coming from the water is accepting electron and becoming H2 gas. So basically it is reduction going on, and the electrode at which reduction goes on is said to be cathode. So you can say that this is cathode. From here you can make a comment that cathode is the one which attracts cation on it during electrolysis. Anode is the one, you see, cathode, cation. Anode is the one which attracts anion. So anode is actually a positively charged in electrolysis setup, not in everywhere, right? In electrolysis setup. So at cathode we have 2H plus 2 electron forming hydrogen. Then at anode there has to be, this is reduction going on, oxidation going on. So for oxidation, what we are supposed to do, the OH minus portion will release its electron, will become, I will tell you the step by step thing. Like it releases an electron, it becomes what? It will become OH dot, OH dot will combine, two OH dot and OH dot, just like hydrogen will combine, and it will become H2O2, which will decompose, will give you H2O plus O2. So at the end, I should write over here that you have to write like H2O along with oxygen, and just check it out that H plus will also be released in this process. You just try to balance this. O2 and 2H2O, 4 oxygen is there like this. So we have 4, and of course how many electrons? 4 electrons. Just check it out if it is balanced. 2 oxygen here, 2 oxygen, 4 oxygen, 4 H plus. So like this you can expect, my dear. Okay, like this you can expect. But quite often the reaction at cathode is not represented in this way. The logic behind it is that because this value is very less now, so actually you have to involve writing water in it. So how do we do that? How to involve water? That is so simple. H plus plus OH minus is there, and if you do 2H plus and 2H minus, and thereafter you start writing the process of reduction, and you just simply add them. So you can write basically H plus is gone, so you can write 2H2O plus 2 electron forming H2 plus 2OH minus. So this reaction is written, this is preferred over this one, right? So because this is showing you the reduction of the water rather than H plus ion, because that is very low in concentration. So please guys go ahead and write this whole thing. Electrolysis of alkaline water.
Sir,
Yes.
sir, this we have to write or okay, so now it
Or
is changed.
is it lagging also? Note it down, everyone. Guys, done? Raise your hand if you're done with it. Please do it quickly, guys. Are you done, guys? Over? Done? Yes or no? Ganesh, done? Abhinay? So if you will not respond if I'm asking, then I will assume that you are done. So if you are not done, please respond that. So this is how I have shown you the overall. So see, the questions like this could be asked in the exam, that during the electrolysis, we used to get hydrogen at which electrode, anode or cathode. That is one. Second question will be, on the other electrode, cathode, you are getting hydrogen, then on anode, which gas you are going to get. So in the electrolysis of alkaline water, as you can see, we are getting oxygen. But my dear, the second one, it's not necessary that to get the hydrogen from that. Na? Electrolysis of brine. Brine means, what is brine? Brine is a NaCl solution of water. Basically, this word is very popular with seawater, right? So aqueous solution of NaCl known as brine, you can see that in that case we have one more negative ion which is more participating than OH minus. So at anode you can see the reaction is changed now in case of brine. Cl minus is forming Cl2 and at cathode, but it is not a complete representation of that. If the concentration of Cl minus is very low, in that case even OH minus will also participate. So sometimes at a node we used to get a mixture of chlorine and oxygen, right? But for now you should write this part only. And cathode as usual. So this is also the second method. Then again there is one more process, as you guys told, I'm just giving you the same thing, that the Bose process, right, which uses steam and coke, and that too at such a high temperature. You can see the temperature, my dear, mind the temperature. It is not happening at ordinary temperature. So if you are thinking that let us mix water and carbon, you will get hydrogen, so it is not possible, right? And interestingly, these method will be used in the preparation of both H2 and CO, right? Right? So I hope you have already written and copied this particular series, which is really important. This one, guys, please copy this. This I'm not going to share any. Please copy this. This is very important. This rough work. This will help you a lot in coming different blocks, reaction associated with that. It will help you a lot to memorize the thing. Please make a note. This is the whole list. Reactivity series. Most reactive and least reactive. Please, quickly. Note it down. Fine. So in the process of electrolysis, I just wanted to add few more points. As I told you, the alkaline water electrolysis, and that is basically used to produce hydrogen whose purity is more than 99.5%. So please make a note. The hydrogen obtained through electrolysis is more than 99.5% pure. Which electrolysis? Alkaline one. Okay. Like barium hydroxide. So you can see that you can say in that way that if we require pure hydrogen, then we can get that from that source, right? All right, everybody. So other part is now one question that I should ask, sir. You should actually ask that, sir, that this electrode, it would definitely be made up of some metal. So don't you think that this metal should also interfere? So yes, my dear, it also interferes. If you have taken platinum electrode, it is the one which is supposed to be inert. So we call it inert electrode. But instead of platinum, if you have taken mercury, then in that case, the mercury electrode prefers, as I told you, that if you have Na plus and OH minus, water is also there. So as I told you, that cation will be attracted on the negative part rather than sodium will not go. But if it is mercury, my dear, then the sodium will go, but H plus will not go. So be very careful. Mercury is very good at forming alloy. It forms alloy with sodium, NaHg alloy, which is exothermic in nature. So quite a stable alloy it used to form, and that is the reason that it prefers metal over H plus ion. It do not follows the reactivity series, right? So please make a special remark with mercury. If mercury is taken as an electrode, then it will prefer the deposition of metals with which it can form alloy, like sodium amalgam. We used to use the word sodium amalgam. Amalgam. So amalgam is an alloy. One component is mercury, other is different metals. So it is sodium amalgam. Like that, even zinc amalgam. Like that, even other amalgam will also be there. All right. Note it down. Okay, that's really great. Now the other methods, as I told you about the carbon plus water, right? Nickel, in the presence of nickel as a catalyst, that too as 1000 degree centigrade, and carbon solid NH2 at that temperature will be steam. So it produces a gas CO plus H2. As you know, this mixture is known as water gas or syngas, synthetic gas, synthesis gas, synthesis, not synthetic. So SYN, short form we used to call syngas. Now, tell me the nature of CO and H2. CO is a triad having bond order 3, H2 is having bond order 1. Bond order 3 makes it naturally very strong. It will not undergo dissociation so easily. And hydrogens, you know that bond of hydrogen to another hydrogen is one of the most strongest sigma bond, right? So if it is the case, then can you tell me how to separate hydrogen from here? Because that will also be a challenge, na? How to get hydrogen from here? Both are gases, both are cryogenic, means they will be existing in the liquid at extremely low temperature. So how are you going to separate them, this H2 and CO? So right now CO is of no use for us, right? So there is a method where CO can be further converted into CO2. So this is known as water gas shift reaction. The CO from here will be reacting with water and it will be forming CO2 in the presence of the catalyst, either iron oxide plus 3 or chromium, or a mixture of both of them, Fe2O3, Fe2O3 plus Cr2O3, chromium plus 3. Okay, so it will be giving you CO2 plus H2. Now it is very simple to separate them because CO2 is acidic by its nature, it is acidic. So when you are passing the mixture from basic solution, then you can get hydrogen will be CO2 will be absorbed by that. So please make a note and write down the name, that Bosch process.
Sorry, your screen share is gone.
Okay, just a minute. Is it okay now? Is it okay, guys?
Yes, sir.
All right, everyone. So this water gas shift reaction you have written. Now through hydrocarbon, you know, through hydrocarbon also in the same way you can produce. This method is known as steam reforming. This method is known as steam reforming. Use any hydrocarbon temperature at this level and it is going to produce CO and H2. And if you want to balance, guys, you can balance it. X carbon is there, so it will be XCO. Right. And similarly, if it will be, if it is X, then you are supposed to X. Similarly, balance the water. If you want a balanced reaction, I will show you. But I would like to give you a few examples so that you can develop this habit of balancing them. Try to balance this reaction. How will you balance when it is propane? C3H8 plus water. Try to balance this reaction. CO plus H2. Try to balance this one. Second one I want to give as C3. Let me take an even number of carbon, that is 4H and 10 H2O, and tell me CO plus H2. Try to balance these two. Try to balance. How you are going to balance? First balance the carbon. 3CO. Yes or no? Hydrogen, you can see that is at two different places. So I think once the carbon is balanced, thereafter you should focus on oxygen and at the end hydrogen, according to me. So according to me, you should first focus on oxygen. So here 3 atom is there. So here 3 by 2. Sorry. Just check it out. 3. So accordingly, now you can balance hydrogen. 3 to just 6 hydrogen here and 8 hydrogen here. So 8 and 6, 14. So 7 H2. Am I right? Just check it out. Is it balanced? Is it balanced, guys?
Yes, sir.
So that's how you have to focus. So balance the atom first, which is present in one molecule only. Like carbon is present here. Oxygen is just present here. You could have started with oxygen, right? You could have started with oxygen. And if the fractional values are coming accordingly, you have to readjust them. So I started with the carbon. Once the carbon is balanced, I try to balance oxygen. Once oxygen is balanced, then I'm just looking at hydrogen because here H2 is there, here it is at two different places, right? Similarly, you can balance here also. 4 carbon, 4 CO, oxygen will be 4. So here you have to take 4 H2O, 8 hydrogen over here and 10 here. 10 and 8 is 18. So means 9 H2. Is it correct? Please write down the next reaction, which is known by the name heating with heating steam on the surface of red hot iron, which is known by the name Lane's process. Lanes, Lane's process. So basically passing steam over red hot iron. As I told you, you can produce the water. You can produce hydrogen from water, direct reaction of water with metals, active metals. Which metal are you can use? So you look at the reactivity series, anything which is above hydrogen in this series. Anything can be used, but the temperature will vary for them. Like I told you, potassium, sodium, they used to react with the cold water. But here you can see that iron is reacting with water at red hot condition, right? So like that things could be used. All right. Now let's talk about, now the preparation is more or less done. If you wanted to note down, you can note down the extra methods also. These are done as per the NCERT, but the extra things you want to write, you write. Extra points. And what are those? Number 1. Okay, you can't expect this. Please make a note on this. You can't expect any product from here as hydrogen. You will never in any concentration. So here what you have to do, basically why it is happening, you can make a remark that nitrogen used to participate. So instead of getting hydrogen, you will be getting nitrogenous product, NO2, N2O, ammonia, right? Ammonia, which will finally convert into ammonium nitrate. So things like this you can expect, not this one. So what are the metals that gives? So as I told you, magnesium and Mg and Mn. Magnesium and manganese, that with very dilute HNO3, they are going to produce hydrogen gas. So here nitrogen is not powerful enough. Magnesium nitrate and Mn nitrate. So these are the only two metals that reacts with this. Okay, so these you can use at extra point. In the extra point you can use sodium active metal. It can evolve hydrogen with the species like triply bond hydrogen associated with triply bond carbon. You know the sp electronegative carbon is having electronegativity close to 3.23, which is greater than nitrogen. So it is enough to remove that. So it will form plus C minus triple bond Cr. Wait, there will be Cr. Okay, and along with that hydrogen gas. So not only that, you can use any HCN kind of thing also. You will be getting Na plus and Cn minus, and again hydrogen. So as I told you that even with water, you're going to get Na plus and OH minus along with hydrogen gas. So you use any acid, NaCl plus hydrogen. So many others. So I told you the boundary line. Yes, tell me, what was the problem? Somebody interrupted me in between. Is there an issue? Is it okay? Fine.
Yes.
All right. Yes. So you can use these extra methods also just to enhance your knowledge. Right. So the next heading you have to put is reactions of hydrogen. Right. My dear, when I'm talking about the reaction of the hydrogen, so directly or indirectly, right? There are many metals which do not directly combine with H2. As you can understand, the hydrogen is having high bond energy, right? High bond energy. So you can't expect that it will react with every single element. But directly or indirectly, most of the element forms hydride, right? Please write down directly or indirectly. Most of the elements of the periodic table form compound with hydrogen. Right? So commonly we used to call these compound, the binary compound with hydrogen as hydrides. Most commonly these binary compound with hydrogen, binary compound with hydrogen is called hydrides. Right? So hydride. So as I wrote here, that most of the periodic table, but not all, right? So the member which do not basically form compound, binary compound with hydrogen is said to be, they are hydride gap. I will show you in the periodic table. What do I mean by that? What do I mean by that?
Sir,
Yeah.
should we write this?
Which one? This one?
No. Yes, sir.
Yeah, it would be better. It's up to you. If you're okay. So the type of hydrides, if I'll describe the type of hydrides as I told you, the binary compound, right? So in the case of hydride, you are supposed to write down right now. I'm not explaining any mechanism right now. Okay, you can write it down. So what are the hydrides? As I told you, hydrides are the binary compound. If I have to classify, I can classify in 3 classes. Number 1 is saline. Saline or ionic hydrides. As the name suggests, it is just like salt structure. It is having things like salt. So in this case, you can consider sodium hydride, lithium hydride, you know, potassium hydride. You can cover, uh, uh, can you tell me the other hydride? Yes, calcium hydride, CH2, and then you can consider barium hydride. So all of these hydrides which have hydrogen in -1 state. H as H minus. So the best point about them is that these metal hydride where M plus and H minus is there, if you are going to take with water, again as I told you, that it is going to evolve hydrogen. So this is also one of the method of preparation, but that is highly expensive, right? MOH you are going to form M plus OH minus. ये base है, this is base. How does it happen? H plus takes out this partially positive, this thing, sorry, H plus, no, not H plus, this is H minus, right? So this H minus gives a pair of electron to it, and this releases the, so basically it forms hydrogen gas along with OH minus. So you can write as hint. Okay, please write it down. These are ionic hydrides. Okay, the general method I told you. There are many reactions I will dictate later on, but first of all, please write down. So ionic hydride. Thereafter, the second hydride is covalent, my dear. Covalent hydrides. So as the name suggests, the molecular hydrides which do not have H minus as the free species, you can consider them into covalent hydride. Now in covalent hydride, further there are 3 classes of that. Electron deficient, then electron rich, and normal hydrides. Electron exact and electron rich. Very simple. You start with the boron family. The hydrides like this: boron, aluminium, gallium, dot dot dot. They are said to be come under this category. Electron exact means you can consider the hydrides of carbon, silicon, germanium, SN. Electron rich, you can consider the hydrides of nitrogen, phosphorus, arsenic, antimony, dot dot dot, like oxygen, sulfur, selenium, dot dot dot, even fluorine, chlorine. So I am using the word, see, with NH3 we have pair of electron. That's why I am saying it electron rich. With boron there is a problem that if you are going to form BH3, it does not exist, 6 electron only. does not exist in free state. Exist in free state. Right. So this is rich, this is deficient. Electron exact means CH4. There is no requirement, no excess electron also. So electron exact, you can quote one example of each. And the last one, but not the least, my dear, is interstitial hydride. Interstitial hydrides. This, right? So saline hydride, covalent, and interstitial hydrides. So interstitial hydride means hydrides. These hydrides, the one which I told you right now, are basically the hydrides of the D block metals. So sometimes it is said to be metallic hydride as well. Interstitial hydride or metallic hydride. Right? Metallic hydride. Okay. Interstitial hydride and metallic hydride. All right. So now I'm expecting you to go through the details of these, right? The details of these with NCERT reading at the same times, any other standard book, whichever you have. Details of that, like many reactions associating this saline. Obviously, you can go few reactions from here and try to read in detail about the interstitial. I'll give you just a hint. You remember I told you in the form of different forms of hydrogen, I told you the hydrogen which is trapped in the metal voids is said to be occluded or adsorbed hydrogen. Do you remember that? Guys, so in that particular portion, if you try to analyze it, that is something which we call as metallic hydride or interstitial hydride. So now the question arises, so many question arises, sir, will it affect the property of the metal like its conductivity? Will it disrupt that? Will it stop the conductivity? Answer is no, my dear, it does not stop the conductivity. What about the other parameters like density and its strength? Like earlier it used to be ductile. Will it be that much ductile? Will the strength increase or not? All these questions are there which you are supposed to tell me by tomorrow. So as if now I would like to stop my lecture over here. You guys just read and practice as much as possible, right? So tomorrow my target will be to cover up the H2O2 portion. H2O2 means at the same time the remaining portion of difference between heavy water and normal water. And then tomorrow there will be a long class, guys. Long class means I will extend the class to probably 2 hour or more than 2.5 hour. Yes. Yes, what happened?
Sir, can you just one show the nodes of Lane's process?
That is iron heated with
Share the notes.
which one you want, the rough one or the fair one?
Fair ones.
Both.
Arey yaar, both.
Yes, sir.
See what is there in the rough notes. You see how bad it is appearing. So that's why it is better to share just the
Fair.
fair notes. Rough